In this video, I'm going to show you how you can come up with the equation of a straight line which is orthogonal to any given random vector. Okay, so this is -2 and 3 up. So this here is at 90 degrees. So we're going to try and come up with the equation of this line. So before we start, cast your mind back to how you would draw a circle. So let's say you're trying to draw a circle of radius 5. So for you to draw this circle, you would demand for any random point, let's say x across and y up, you would demand that this length, the hypotenuse, to be equal to 5. So for example, if you were to look at, let's say 7, 0, if you were to look at 7, 0, this you wouldn't satisfy, because look, 7 squared plus 0 squared square root does not equal 5. So this is a bad point. Whereas 4 across, 3 up would satisfy this, a radius of 5. So basically, to draw a circle, you would demand that the hypotenuse to be of radius 5. You would tidy this up to give you this. So the equation of a circle. So eventually, all these points here would satisfy this equation. So that we should then draw out, trace out a circle. Any point out here, any random point here, this hypotenuse would not be equal to 5. So that would be how you would draw a circle. You would make this demand. And before we start, I need to remind you that the dot product, any given two vectors, well, you're going to have an angle in between. And when it's at 90 degrees, remember, cos looks like this. When it's at 90 degrees, this is 2 pi over 2. When it's at pi over 2 or 90 degrees, you can see that this would be 0, meaning the dot product equals 0. So to make the demand that they're at 90 degrees, you would demand the dot product of two vectors to be 0. We've seen this before, so I'm expecting you to know this by now. Okay, so we're going to make use of this. So let's go back to the beginning. Our job is to come up with the equation of this line here for any given vector. So so now we're going to demand, let's select a random point, a general point. So the coordinates here would be 6 across and 7 up. So we're just going to call this random point at a location of x and y. This general point, we need to demand that this vector here, we need to demand that this vector here to be orthogonal to our given random vector. But we need to know what this vector is. What is this vector? It's not simply xy, because xy would be 6 across and 7 up. What is this vector that would take us from A to B? So the vector from A to B, you've got to imagine. Well, let's just from the origin. That's this vector here, and then from the origin, that's this point here. How would you get from A to B? Well, you imagine you are here. You would need to go back to the origin. So going back to the origin from A would be you moving -4, and then -2 down. So -2 down. So this is really your starting position here. So you've got to take that into account. So moving from A to the origin, and then from the origin, then you can get to point B. So that would be plus. Remember, point B is x and y would be x across and y up. So that would be this, x across and y up. So this is how you would get from A to B. So basically, this thing here is the vector that would take you from A to B. So, well, you would tidy this up as this. So the vector that would take you from A to B is actually this, y take away 2. So basically, this is your starting point here. Hang on. So this is a vector. So to come up with the equation of this line, you would demand the general vector, which is this thing here, to be orthogonal to our given random vector. So you would demand this. So to come up with the equation of this line, you would make this demand. I demand the given random vector. I demand this vector to be orthogonal to our general vector. Hang on. I demand this to be equal to 0, because when two vectors are orthogonal to each other, the dot product equals 0. So if you select any point on this line, you see this vector here would be at 90 degrees. Let's say you select this point here, the vector from here to here, it would be at 90 degrees to our given random vector. If you select a point out here, that would not be good, because this vector here would not be at 90 degrees. So for you to come up with the equation of this line, you would need to make this demand. So let me tidy this up, bear with me, hang on. So you would need to make this demand. So now tidy this up. So remember the dot product would be this times this, so that would be minus 2 bracket x minus 4 plus this times this, 3 bracket y minus 2 equals 0. And then now just tidy this up, so that would become negative 2 plus 8 plus 3y minus 6 equals 0. So that would be, this thing here would be positive 2. So you take away 2, and then you've got this thing here, and then you would rearrange it. So add 2x to both sides. So that would then give you this. Y equals add 2x to both sides, and then divided by 3. So this is the equation of our line, which is orthogonal to our given random vector. There are easier ways of obtaining this equation, but learn to do it the dot product way, because later on you can extrapolate it to 3D. So given a random vector in 3D, you can do a lot more things if you use this approach. Okay, so basically, in short, you need to take into account your starting position and your random given vector, and then demand that the general vector, let's say this vector here, the general vector, demand the general vector. So x, your starting position, which is 4 across and 2 up. So you need to take your starting position into account, which is here. You need to demand that the dot product with the random given vector to be 0. And then from this would eventually lead you to the equation. Okay?